Swayam Prabha. Digital India. Educated India.
Hello and welcome to the 8th lecture on the series on Fintech. In this lecture, unlike the previous 2 lectures where we actually looked at certain domains of Fintech like payment systems and lending systems, P2P systems, card systems, we will again go back and look at one of the fundamental technologies which is the foundation of lot of Fintech systems today. We might have heard of the products using this technology. Must have heard of cryptocurrencies, Bitcoin. They are all built on this foundational technology called blockchain. Many of you might have heard of the term blockchain too. Blockchain has applications not just in Fintech, in pretty much a vast domain of human endeavors, business, commerce, governance, social interactions, but the biggest application of blockchain is in the field of financial services and Fintech. So, let us take, for those who are interested, I have delivered a series of lectures earlier on blockchain alone. If those of you are interested in more details about this lecture, please go back to that series. In that over 10 lectures, we explored this concept in more depth in terms of what it is, how it is useful, what are its advantages and things like that. For the purposes of this lecture, we need to briefly understand what it is or do a recap of what we studied in that series of lectures. So, we will take a look at that today. Also look at some examples of Fintech where blockchain is the foundation of that particular product or technology. My name is Dr. Sudhendra Hanumanta Rao. I am the Dean of Faculty of Management and Commerce at Manipal University in Jaipur. Let us get started. Let us understand the basics of blockchain. Before we go into see what exactly is blockchain, let us understand some basic characteristics, fundamentals to see why it is called blockchain and what it is and why it is so important. One is, it is called a distributed tamper proof public ledger. Generally, there are other types of blockchain too which are not public, which are private and things like that. In general, it is a distributed public ledger and tamper proof. Tamper proof means if somebody tries to transactions, remember one of the key elements of information security is integrity. Only those who are authorized to make changes, authorized to record a transaction, authorized to make a transaction should be allowed to do. Once a transaction is settled, nobody should be allowed to go back and change them. That is like committing fraud. So, if somebody tries to commit fraud on a blockchain, either it is impossible or becomes evident that they have done it, so that we can take corrective measures. That is one key element. That is what brings strength to a blockchain. It is tamper proof or tamper evident at a minimum. Second, it is distributed. Generally, blockchain is a ledger. Ledger, for those of you who have a foundation in accounting, you know a ledger is a recording of all transactions. We sell, we buy, we pay somebody in salary, we take money from the bank, we put money back in the bank, we make payments for our purchases, we take money from our customers. All these are transactions. There are financial transactions, there are physical transactions. Things like inventory systems, sales systems and all keep track of physical transactions. Financial transactions are all written in a book called a ledger. We write in when money came in, when money came out, why it came in, which account it went to, which account it came out of, all these details. So, if you want to understand the finances of a company, we need to go through the ledger. That is where all these transactions are recorded. Blockchain is that, it is a ledger. At heart, it is nothing more than a book of accounts, but with very distinct characteristics. One is majority of them are public. For example, Bitcoin blockchain, Bitcoin's ledger, anyone can download the Bitcoin software and look at all the transactions that have happened. We can look at all the transactions which has happened since inception, make sure that it has actually happened. So, if somebody claims that I received 5 Bitcoins from person A on such and such a date, before I sell this person my house in exchange for those 5 Bitcoins, I can actually go to the Bitcoin blockchain and see whether this person actually, how did this person get those 5 Bitcoins. He might have sold something to somebody, he might have purchased Bitcoins on an exchange. So, I can verify and make sure that this person indeed has 5 Bitcoins. I do not have to trust his word, it is there in public and nobody could have changed that. Once it is recorded that person B has 5 bitcoins in his possession, he has received 5 bitcoins, I do not need any other proof that this person does indeed have. So, I can safely sell my house. Remember, when bitcoin is worth $50,000 today, 5 bitcoins means $250,000, $250,000, almost close to 2 crore rupees. So, I can safely sell my house to this person. I do not have to trust his word, I can trust because of the nature of the blockchain. It is a ledger, it is publicly available to me and nobody can easily tamper that. So, if a transaction gets recorded, it is there and I can trust that. Nobody can easily fudge that, nobody can easily hack into that, and by nature it is distributed. Again, this applies only to public blockchains, we will see what it is. There are private blockchains where it need not be distributed. Distributed means if there are 10,000 people using this particular blockchain like Bitcoin, there may be millions of people using the Bitcoin, transacting with Bitcoin, trying to mint Bitcoins, doing business using Bitcoins. All 10,000 of them will have a copy of this ledger. So, even if somebody by chance gets a chance to corrupt my ledger, somebody is able to, I am very lax in my security policies, somebody hacks in and tries to change my ledger, my blockchain, they have to go and change it in every 10,000 of them, not easy. So, if somebody brings down, forget hacking, hacking is not easy, somebody may simply set off my system, they may crash my hard disk, my blockchain may get corrupt, but the system will not get affected. There are other 9,999 other ledger copies of the ledger with others and system will run because of them, and at some point I can copy it back to them. So, nobody can bring down the system very easily because of the distributed nature of the blockchain. And further we will see a term called distributed consensus. If I want to add a new transaction, I am selling my house to person B and he is giving me bitcoins. This should get recorded in the ledger, right. Somebody should make a ledger saying that I, Sudhendra Hanumantrao, has these 5 bitcoins belong to Sudhendra Hanumantrao. In transaction I have given that house to my house, sold my house to that person. What if somebody wrongly tries to do this transaction by fraud? Somebody wants to steal 5 bitcoins from person B, person C will try to make an entry saying that I have taken 5 bitcoins from person B and wants to enter into that ledger. For this ledger to be approved, every party, a majority of the 10,000 participants in this ledger have to agree on that transaction, and they will only agree if certain conditions are met. Those conditions are set in stone, those conditions cannot be violated by anyone. Only when somebody meets those conditions, maybe like for example, I have my digital signature, I have to agree to this transaction, person B has his digital signature, both of us have to put our digital signatures, and the remaining 9,998 participants, a majority of them, have to verify this only when this transaction gets recorded into the ledger. After that, it will reflect the fact that Sudhendra Hanumantrao has 5 bitcoins, person B has 0, he had 5, now he has 0, but there is a record saying that he has bought my house. So, if person C tries to do that, his digital signature will not match either of us. He is the one who has the bitcoin, he has to sign person B. I am doing the transaction, I have to sign, it has to match my digital signature, and other 9,998 users will easily find out that person C's digital signature does not match. So, nobody can add transactions unless the majority agrees, and they agree only under certain conditions like digital signatures matching, which apply to everyone. So, this is called distributed consensus. So, when a transaction is there in a blockchain, in a public blockchain, I can trust that it is a valid transaction. It is a transaction is valid, it is authorized or verified by more than half the users, and once the transaction has been entered, it has not been tampered with. So, these are the strong points, these are key strengths of blockchain which gets leveraged again and again and again. So, in normal financial transactions, we trust a third party. In the chapter on money, in the lecture on money, I explained this particular piece of paper, we trust it is worth 500 rupees, it is worth 1000 rupees because Reserve Bank of India tells us, we trust Reserve Bank of India, hence we accept that money. That piece of paper whose actual value will be 20 paise to produce that, but we accept it as equivalent of 1000 rupees because we are trusting somebody. We need a trusted person to make the transaction happen, which is common in every aspect of business. Every part of business, every transaction, We do it because there is some trusted party guaranteeing that. What if the trusted party is corrupt? Then we have no recourse. That aspect is removed in blockchain now. I can trust because a transaction is in the blockchain, I can verify. I do not need somebody to tell me the transaction is there, I can go and verify. I can trust because I know that transactions cannot be entered unless it is verified by majority of participants, number 1. That means, if it is corrupt, all of them have to be corrupt, which rarely happens. And number 2, once the transaction has been entered, nobody can alter that. So, it is and nobody can bring down the system easily because there is a copy of the ledger with everybody. So, it is a distributed tamper proof public ledger. As I said, I have explained this in more detail in the other series. It is based on 3 basic pillars. One is distributed or decentralized. If the copy of the ledger with everyone, if somebody brings down one system, if somebody brings down 10 systems, still they cannot bring down the whole network because it is equally spread upon everyone. Consensus. Second is consensus. All actions, all entries to the ledger are made only if majority of the participants agree. Only then, under standard conditions, the conditions are known, they are all set up in what is called an algorithm. Only when the algorithm is formed, all the other parties will trust the transaction, they will approve the transaction, only then it goes into the ledger. And cryptography. And all of these activities are secured using cryptography. Cryptography is the foundation of blockchain. We will see how that works a little later. So, these are the key: decentralization, consensus and cryptography. Together they ensure that whatever we see there, trust is established transparently. I do not have to depend on third party. I can go and check in the blockchain and verify that I can trust this party, I can trust this transaction. If B says he has 5 bitcoins, I can go and verify, and if it is there, I can trust that this person, because we do not see generally, except in face to face cash transactions, we do not see parties on the other side today, especially in Fintech, we rarely see the other party. So, we do not know who that person B is. He could be in Mongolia, he could be in New Zealand, he could be my neighbor, I have no idea who they are, but I can trust because it is there in the blockchain. Transactions are time stamped, we can only be updated forward, we cannot go back and change transactions in the past. If we want to change the fact that B has given me 2.5 bitcoins, that will be recorded in the future. After that, it will reflect that B has 2.5 bitcoins, I do have 2.5 bitcoins. And forward updating, that I have been saying. So, at any point, if the transaction is time stamped, it cannot be changed, we can only update moving forward. So, we cannot change data retrospectively. Typically frauds, lot of frauds happen like this. Transaction gets recorded as A, actual event is B. At a later time, when nobody is looking, the person will go and change the transaction A to B. Here it cannot be done, it simply cannot be done, or let us say theoretically it is not possible, let us put it that way. And a blockchain is called a blockchain because it is a chain of block. What is a block? A assembly, a set. Each block is a encodes one or more transactions. A block contains details of one or more transactions. To give a rough idea, a Bitcoin blockchain approximately has 10,000 transactions. Every block that added to the Bitcoin blockchain has details of 10,000 transactions. Chains of block is a hash chain, I will explain in the next slide what it is. And blocks, it is a chain of single set of blocks. At any point there will be one set of blocks in the chain, there are no branches. Suppose, and there is a way to add new blocks. If two people try to add a block, only the valid block gets added. Let's suppose this valid block gets added here, this invalid block gets added here. The further blocks follow this chain and go further. Only valid blocks get added along this chain. This chain will not grow because this block is invalid. So, if somebody tries to wrongly enter a block simultaneously as another person is entering a right block, over a period of time, thanks to various verification mechanisms, the block grows in this way. After some time, this branch gets discarded. So, at any point only one branch, one line of chains will exist. So, this process is called forking, breaking it into two branches. It has happened in some cases with the approval of all users. A blockchain has been split into two blockchains. It has happened to Bitcoin. There is what is called Bitcoin Classic, which is going along this line. Simultaneously, one more Bitcoin block called Bitcoin Cash is growing on a separate chain. Both are individual chains now. This link is no longer there. The Bitcoin itself was broken, the forking, it got forked into separate chains with the approval of all the participants into Bitcoin Classic and Bitcoin Cash. Such things are possible, but only with approval. Otherwise, if somebody tries to do it unauthorized in an unauthorized manner, this gets discarded, only the valid chain grows. So, at any point we can be sure that in a valid Bitcoin there is only one chain of blocks. Anyone can search, browse and verify the block. This is the beauty. This is what establishes trust in the process. Anyone in an open public, there are varieties of blockchains, I am talking about the most public of them. In a public blockchain like a Bitcoin, anyone can download that, we can search for any transactions, we can browse, we can verify that the transaction actually happened. That is how we can trust. We do not have to believe in the words of anyone else, we can verify. And as you can see, when I can trust some party without even talking to that person, we do not need a third party to verify that. If somebody says he has a Bitcoin or a Litecoin or a Dogecoin, what have you, or Ethereum, I can verify that. I do not need a reserve bank to guarantee or assure me that that person has. If he shows me some signature or some transaction, I can go and check, verify. So, it removes this whole list of intermediaries. Remember, financial services is full of intermediaries. Ultimately, what is finance? Person A and person B, two people do a transaction, but we have this whole industry in between which helps us trust person B, and person B trust person A, make sure transaction happens. Here that whole thing has been removed. So, that is why it is such a powerful tool. It can disintermediate, it can truly bring P2P into fruition, and indeed not a surprise, most of the P2P systems today are being built on top of a blockchain, not just in finance, in every other field too. So, these are the fundamentals of a blockchain, and this is how a blockchain looks. Let us say this arrow is not there, this is the origin block, the first block. The second block was developed. As number of transactions increased, the second block was built. It was built by taking the data and encrypting that and putting a timestamp when this block was created, and a hash of this block was calculated. Remember, what is a hash? It is one way encryption. It results in a fixed size block, fixed size message, fixed size string, 128 big. However big this block might be, the hash of it results in a fixed size of this. So, when I want to add this block, I take all the data, encrypt it, take this block, take a hash of that, include that here and put a pointer. So, this actually works in the backwards way. What it means is, I have added this block with this data encrypted, I have calculated the hash of this block 1, and this block pointer says where it is drawn from. This pointer, this hash is drawn from this block, this whole data is put in this hash. The thing is, and I put a stamp, timestamp, encrypt all of that, add and put a pointer from that hash to this. The thing is, by design, calculating this hash is a very time consuming and computing intensive activity. That is what makes it so tough to build a block. Anyone can easily add a block, but deliberately it has been done that to add this hash, I need to calculate a very complex mathematical puzzle, so to say. Only when I do that, I will be allowed to hash this and add it and add the block. This process of solving that puzzle, calculating that hash and adding this block is called mining. We will see the importance of mining, and once I mine this block, I am allowed to add this block. In various systems, I am given a reward, then somebody else can calculate the block after that as transactions accumulate, keep adding like that. So, block keeps growing as people collect all the transactions happening on that blockchain, encrypt it, calculate the hash of the previous block, add that into their block and add a pointer to make the blockchain grow. Do remember one thing, the hash here depends on the data here, right. The what exactly is the string here? If I put a different string, different hash results. So, but for this data there will be only one hash, it depends on the data here. The hash of this block, when I want to add this, depends on the data here, which depends on the data here. Likewise, every hash has a dependency going all the way to the original block. We will see why it is important. Okay. So, the hash here does not just depend on the data here, it depends transitively, it depends all the way all the way to the data in the very first block. So, now let us say, so I hope all of you are clear on what a blockchain is. It is a block of transactions with a hash of the previous block, which depends on the hash of the previous block, which depends on the hash of the previous block all the way to the origin. And by design, calculating this hash has been made very complex. So, it is not easy to add blocks, it requires a lot of computing power and time. Having said that, let us consider a case where somebody wants to go and change a transaction retrospectively here. Somebody wants to commit a fraud, instead of 5 bitcoins going from person C to me, they want to change the transaction saying that person B to me, they want to change the transaction saying that 5 bitcoins went from person C to person B to person C. Suppose they want to change this data, what happens? The hash here depends on the data here. So, these two hashes do not match. If I change the data here, this hash does not match. Other people will catch it immediately. They will compare that with the copy of the hash they have, which does not match the hash that I have added here, and they will catch me out and revert the transaction. So, for me to make this transaction valid, the fraudulent transaction valid, I have to go and change the hash here. I have to go and change the hash here. I have to go and change the hash here all the way till the end. Only then, if I am able to do that successfully, will everybody recognize, since the hashes are valid now, they will recognize this as the new transaction, valid transaction. But think what is happening. This is a very complex operation. Calculating this, changing this hash is almost the same as calculating a new hash. Not almost same, it is the same as calculating a new hash based on new data. So, by the time I calculate this hash and change this block, one more or more than one block would have been added here. By the time I change the next hash, one or more would have been added here, and they all take the same time. It takes as much time for me to calculate this hash as much time as it takes to somebody, and if multiple people are doing it simultaneously, they may be able to do it faster than me. So, I will never be able to catch up, and at any point I will be caught and my transaction will be thrown out. So, if I want to change a transaction here, I have to change all the hashes in all the subsequent blocks, and by the time I do that, more and blocks will get added and I will never be able to catch up, my transaction will get reverted. That is why we say either it is obvious that somebody is trying to make this change, it is obvious, and I will not be allowed to do in many cases. I simply cannot catch up, there is not enough computing power for me to match the computing power of all the other participants put together. So, that is why we say blockchain is tamper proof. If a transaction gets done on the blockchain, changing that is practically impossible. Amount of computing power is required. Theoretically, there is a slim possibility, and I will not go into it. There is something called a 51% attack, where such a thing is theoretically possible, but in practice it has not happened, at least on the Bitcoin. So, that is how blockchain is very secure. It is not easy to go and change, because we have to change all the things simultaneously. When that is happening, other blocks are getting added. Okay. So, some more details. By definition, who can add? The question is, who can add this new block? In the case of banks and financial institutions, the intermediaries, banks will maintain these accounts. They will essentially do the maintenance of this block, or my stockbroker, the stock exchange, various parties keep track of, they have an interest, they make their business out of it, that is why they maintain. In case of blockchain, who maintains these records? Who adds these records? The ledger is public, but who maintains it? Some or all members can add blocks, and others verify validity based on transparent rules. In Bitcoin, it is very clear who can add a block. Anyone who can solve this mathematical puzzle and who can accumulate those 10,000 transactions, the first one who does it, the fastest one, gets permission to add the next block. When I say I have calculated this hash, this is my hash, all the other participants verify that, they give me approval. Once they give me approval, I can add the block. Why do I do that? There is a reward for that. It is a reward system in Bitcoin. different blockchains have different reward systems, but for the purpose of that reward I maintain the blockchain. I maintain the blockchain, I do the mining, the process is called mining. So, some members are all members, and the beauty of some of these blockchains, Bitcoin especially, is that I do not need to own Bitcoins today to be able to add a new block and earn Bitcoins as my reward. That is the nature, that is the way Bitcoin has been designed, that is the way most cryptocurrencies have been designed, but there are private blockchains which do not work that way, in which case one set of parties are allowed to, the people who own the blockchain are allowed to do the mining, they are allowed to do the maintain the block. So, but in most common cases anyone can do the maintenance and be rewarded. Security and integrity are achieved by cryptography as always. It is a combination of hashing, symmetric encryption and asymmetric encryption. Remember PKI, public key infrastructure, where there are different keys, one to encrypt and one to decrypt. All the transactions are signed using digital signatures, which are a variant of, which is a type of asymmetric encryption, whereas the blocks are linked using one way encryption called hacking. Many of the blockchains have an incentive to maintain. Maintain means what? I verify and add new blocks. For that there is an incentive. On Bitcoin, if I am able to verify and add a new block, I get X amount of Bitcoins as my reward. Right now I think it is about 2.5 Bitcoins, more than $1 lakh. And as I said, there are multiple types of blockchains, there are 4 varieties of blockchains. We can classify them based on ownership, we can classify them based on who can use that blockchain, who can access that blockchain authentication. By ownership, blockchains can be public or private blockchains, and by authentication it can be a permissionless blockchain, anybody can access it, anybody can mine it, anybody can maintain it, or it could be a permission blockchain. So, we can see 4 combinations: public, permissionless blockchain. It is a public blockchain, anybody can maintain that, anybody can use that, anybody can verify that. Most cryptocurrencies come into that category: Bitcoin, Ethereum, Dogecoin, Ripple. There are public permission blockchains. I have explained this in the other lecture. Public blockchain, but to log in we need permission. We need to set up our account in some form using KYC and things like that. Other combination is private permissionless blockchain. Not too many examples, but I have given a trivial example in the other class. It is maintained privately, owned privately. For example, JP Morgan, the company, has issued its own digital currency. It is done on a blockchain. It is a private blockchain. It is their blockchain, they maintain it. They may allow permissions, people to look at it, anyone can, or they may put a permission. Only people allowed by JP Morgan Chase can look at their blockchain. So, these are the 4 types of blockchains. When people say blockchain, they essentially mean a public permissionless blockchain like Bitcoin. But remember, it is other private blockchains which are growing faster today. Lot of organizations are building Bitcoins, they all are private, they maintain that, nobody, they do not give the permission. They may not even let everybody look into that also. It may be a private permission blockchain. This is a bit of the technical structure within a blockchain. So, let us not worry about it, I will skip over this. It talks about public key, hash, signature, various things. And generally the economic foundation is that blockchains maintain, public permissionless blockchains, they maintain themselves because there is an incentive to maintain. Anybody can maintain, we get incentives. So, everybody competes to maintain the blockchain. Everybody tries to mine in the Bitcoin world, everybody tries to mine in the Ethereum world, because there is an incentive for that. So, who should be allowed to do that? Building and maintaining by adding new blocks and verification of new blocks. These are the 2 activities required while we maintain a Bitcoin. So, whom should we give an incentive to maintain the blockchain? Remember, these public blockchains, they give an incentive to do this activity. So, everybody wants to do. Whom should we give it to? Whom should we give this incentive when a lot of people are competing for that? There are 2 most commonly accepted ones. One is called proof of work, another is called proof of stake. Both are attracting lot of discussion. There is a lot of activities happening on both ways. Let us not go into details of them. I will briefly touch upon the differences between them. Bitcoin follows the proof of work method to incentivize. So many people are trying to add a block, and Bitcoin decides on whom to give that right to add the next block based on what is called proof of work. That is, whoever does some amount of work first, they are allowed to do that. This is how it happens. There are so many miners, so many people trying to calculate the next block in Bitcoin. The miner is allowed to add a block after doing some work like solving a complex puzzle. In case of the Bitcoin, we have to calculate that hash. Calculating that hash requires solving a very mathematically complex puzzle. It may take days together. For a bank of computers, 10,000 computers working together, they may be able to add a block after 2 to 3 days of work. And whoever says that I have calculated, solve this puzzle first, so this is my hash, they have to announce it to the whole Bitcoin world. All the other participants verify. This is one of those calculations. There are certain types of mathematical calculations which are easy one way and complex the other way. Like for example, a square root of a prime number. Like for example, there is the number 729, if I am correct. This is 23 into 23. If I may be wrong, please pardon me. So, if I ask you to break 729 into its factors, only possible factors is 23 and 23. It takes far much more time than telling you 23 and 23, tell me the product, comes to 729. So, this is an operation where it is easy to calculate this way, very difficult to calculate this way. So, these algorithms take advantage of this. So, calculating the hash, that is breaking this into two things, is very difficult, but the moment I say 729 is the product of square of 23, somebody can multiply that and find that much faster. So, when I calculate this hash and announce, it takes taken me a lot of effort to do that, but the moment I announce, it is much easier for other participants to verify. If they all verify and agree, and I am the first one who has done this, I will be allowed to add the next block. I can calculate I can capture all the transactions, encrypt them. I have already calculated the hash, put it in that, put my timestamp, put my signature. I am allowed to add the next block. So, block is added after consensus verification. The beauty of that, as I said, it is very tough to create a new block, but it is very easy to verify it is a valid block or not. That is why all the other participants verify that. There may, depending on the blockchain, even those who verify may also be given an incentive to verify that block. They may also be given an incentive to verify that a transaction is valid. We do a transaction, I sell my house to B, B sends me 5 bitcoins. Somebody has to match our 2 digital signatures and verify that this transaction can be added to that block. Not talking about mining, talking about individual transactions, 10,000 of which go into the block, and for that also there may be a small incentive, otherwise why would somebody verify? So, there may be an incentive to do this transaction also. In any case, depends on how the blockchain is being set. So, transactions are verified, block is verified and added, that is how the blockchain maintains itself. Miners get an incentive in the case of Bitcoin. In case of other cryptocurrencies, others also, those who verify also may get an incentive, depending on how that blockchain is structured. This is one way. Everybody competes, does a lot of work, whoever does the work gets the next alternative. The other thing is, choice is given to those who have the highest stake in the system. For example, if I were to take in Bitcoin, whoever has the highest number of Bitcoins will be allowed to add the next block. But that means they will be getting the choice every time. So, there is a probability at random, all the users, let us say 10,000 users own Bitcoins in various numbers. At random, it is like drawing a lot, and everybody stands a chance, but those who have more stake, those who have more Bitcoins will have a higher probability. Suppose there are 100 Bitcoins in the world or 100 cryptocurrency in the world. Somebody owns 50, somebody owns 10, somebody owns 1, somebody owns 13. For 50, we put 50 like TT balls with their name in a bucket. For those with 25, we add 25 balls. Those with 10, we add 10 balls. We shake them thoroughly, pull one ball out. Whosoever ball we pick, they get the next choice to add the next block. So, as you can see, if somebody has 50% 50 balls out of 100, if they own 50 Bitcoins out of 100 in the system, they get more opportunities. but somebody with just one in the system, one ball, one Bitcoin in the system also has a probability of being picked. He may just unlucky, that is all. That is a probability, that is the beauty of probability. Those who have a higher stake in the system have a higher possibility, but no means they are guaranteed. Using such a system, every time a new block is to be added, we shake these balls, pull one out, whosoever number comes up, they are allowed to add the block. Again, once they are done, we again shake, put number. This is called proof of stake. So, there is no competition, people do not waste here. The problem is, it is found that they waste a lot of resources, and as it happens waste a lot of electricity, and only one person gets the choice, all the others lose their effort. Here not so, we pick the person and reduce the effort. So, there are benefits to the proof of stake system. Miner is selected randomly, weighted by the value of current holdings. Those who have more value in the holdings, they get a higher probability. Verification may not be necessary, because only that person is allowed to do, there is no contest, but it is verified for security anyway, most of them do verify. There are systems which work on proof of stake, there are systems which are working on proof of work. Blockchain is still on proof of work. So, that is how blockchains maintain themselves. This is a typical transaction, I will not go into it. There is the buyer, there is the seller, there is a third party who validates the transaction. In blockchain, the transaction goes into, it goes as one of the transactions into a block. Whenever a transaction happens, A wants to send money to B for buying something, that transaction goes into the distributed among all the players in the block. Every party, if the transaction goes to every party, they verify and approve the transaction. They check that person B has 5 bitcoins, I own the house by some way, I have scanned the document. They verify that both they have, they approve the transaction. Once they approve the transaction, it goes and gets added to the block. Once the block, what is the meaning of transaction being added to the block? It reflects the current state. Once I sell my house to B, the house is with B, the 5 bitcoins carry my name. So, that is the meaning of transaction getting entered. When all the parties agree, it goes into the block, it gets recorded. Now, this new database which has all the transactions gets distributed to all the parties, everybody updates. So, at any point you do not have to come to my copy of the blockchain to verify that I have bitcoins now. You can go to somebody else's blockchain who is accessible to you. Their blockchain also has all the transactions. It will show that after this transaction has been added, now Sudhindra Hanumantrao has 5 bitcoins which he got by selling his house. So, no trusted party, all the transactions are reflected and available to the public. So, in that sense there is no third party, only buyers and sellers, others only verify the transaction, they do not validate or guarantee the transaction. And there is something called smart contracts. So, that is in the cyber world. How do we make sure in this example, for example, that I have actually given the possession of my house to person B. He may be ready to send me the bitcoin. What if I take the bitcoin and send him a fake document? One way to avoid such a scenario is to enforce what is called a smart contract. We can agree, I will just briefly touch upon this topic because it is quite a complex topic by itself. We will both agree that I give you my documents to my house and you give me the bitcoin after verifying that the documents are genuine. So, we can draw up a smart contract. The moment I send you my documents, it gets recorded in the smart contract that I have sent the documents to person B. Who verifies the document? We may engage an attorney, we may engage a notary to look at my documents and verify that the documents are genuine. Person B makes a record that if the documents are genuine, these 5 bitcoins should be transferred to me. So, this third person now in the smart contract looks at the documents, checks with the records in the government, verifies that these are genuine transactions, approves. He goes to the smart contract, checks a box saying that these house documents are genuine and given to, I have given the possession to person B. The moment that person does the transaction, the smart contract fires, it automatically removes those bitcoins, 5 bitcoins from person B, puts my name on those bitcoins. So, that way documents transferring is a real time activity, whereas bitcoins being transferred is a virtual activity, it is happening in the e-world. So, these two are linked by means of a third party, that third party verifies that the documents are genuine. Once the transactions are genuine and certified and given to that person cannot stop those bitcoins from transferring to me, because there is a smart contract which does it automatically. Simultaneously, if my documents turn out to be fake, that this person, the notary, will make a notation that these documents are fake, the transaction gets reverted, bitcoin's names do not change, they go back to person B and I am left with my fake documents. So, smart contracts are the ones which bridge the fintech or e-commerce world with the real life world. So, that is what has made blockchains much more powerful today. We are just not looking at a ledger, just a transaction of documents. It can also make sure that the document has been done, the transaction has been done. Examples where blockchain is been deployed: Bitcoin, as I have said, Bitcoin in fact was the first successful demonstration of a blockchain. Before that, blockchains had been talked about in concept, had not been implemented. Bitcoin is the first one which came with a blockchain. That is why people confuse Bitcoin and blockchain. Bitcoin is a product, a cryptocurrency. The technology it is implemented is the blockchain. It is the first successful use of blockchain. It is the most prevalent cryptocurrency. In fact, there are cryptocurrencies linked to the value of Bitcoin itself, like Litecoin, other things like that. Very well accepted, supports micropayments. It is based on a public permissionless blockchain. For maintenance, it uses a proof of work scheme of incentives. Blockchain is built by miners who prove that work, do the mining and who solve a mathematical computation algorithm and keep adding new blocks. Verification done by consensus. One characteristic of bitcoins is how do new bitcoins get created. In the outside world, RBI prints notes whenever it thinks it is sort of appropriate. How do bitcoins get created? Whenever a new bitcoin is mined or added, certain numbers of new bitcoins have been created. It gets issued automatically into the system. Now it is I think 5 or 2.5, one of the time. Let us say it is 5. So, when I pass the algorithm, I create the algorithm, get verified, calculate my hash, I add 5 bitcoins, new 5 bitcoins get created and they get given to me. That is how new bitcoins get added. However, there can only be a total of 21 million bitcoins. The Bitcoin application, Bitcoin program has been written in such a way that new coins do not get added, they get added only up to there are 21 million bitcoins in the system. After that it stops. So, what happens? Number of transactions keep increasing, but we are using only the 21 million bitcoins. So, what happens? The cost of the items keep reducing, because there are fixed number of bitcoins, we are buying more items as we are over a period of time. If we do more transactions using bitcoin, the price of items in terms of bitcoin comes down. Their price may not come down in terms of dollars or rupees, it may come down in bitcoins. So, that is why we say bitcoin is deflationary for a period of time. Once 21 million bitcoins have been issued, it stops. As I said, there are now two types of bitcoins, Bitcoin Cash and Bitcoin Classic. Bitcoin is not under the control of anyone. It does not need a reserve bank to verify that, right. So, it is global in nature, it is not under anybody's control. It is called pseudonymous. I do not have to reveal that I am Sadendra Hanumantrao. I can call myself anything. I can call myself as Mr. Bond, I can call myself as Mr. James Bond, but all the transactions under me will carry the name Bond. Transactions are done by Bond. Somebody looking at and say Mr. Bond is doing all these activities, but they cannot pin it down to me. So, it is called pseudonymous. So, that is one of the characteristics of Bitcoin, it is not under the control. So, if they want to audit, if RBI wants to find out who is doing, I may be buying drugs, I may be buying weapons. If the government authorities want to know who is this person who is doing all these illegal activities, it is not easy for them to find out. So, that is why it is suspected, many governments suspect cryptocurrencies, they do not allow, they make it illegal for reasons like this. Thanks to its global nature and pseudonymity it offers, it is suspected of using for money laundering and other such illegal activities. That is the downside, but there is a way to control that. Some countries allow, some countries absolutely say no to all these cryptocurrencies for that reason. We need to be aware of that. These are some of the downsides of these cryptocurrencies. Ethereum is the second biggest Bitcoin. It is also a public permissionless blockchain. it also has its own currency called Ether. Its incentive was based on proof of work, it is moving into proof of stake. The beauty of Ethereum is not just a cryptocurrency, it also allows us to build new blockchains. It has smart contracts and its solidity. Unlike Bitcoin, which does not support smart contracts, Ethereum supports smart contracts. It has been broken. It allows us to develop new blockchains using that platform. Bitcoin blockchain, there is only one of it. It has been forked, but there is only one. I can use Ethereum to build my own variety of blockchain, which need not be linked to its own cryptocurrency. I can develop my own cryptocurrency using the Ethereum platform. So, this is another application of cryptocurrency. There is a lot of support for this, because we can use it as a platform to build new Bitcoins. So, things like Microsoft and all other companies have formed an organization called Ethereum Enterprise Alliance. They published new standards to build new blockchains. That way Ethereum is more useful in the real world other than its cryptocurrency. However, Ethereum's own cryptocurrency also is the second most traded currency after Bitcoin. There are so many examples, I will give you some more in Fintech specifically. Before that, let us briefly touch upon advantages and disadvantages. One is, we know it enables transparent trust. We do not need a third party. Using a blockchain, I can automatically look at the blockchain and trust a third party without knowing anything about them, including their name. So, the distributed consensus ensures trust inherently and can eliminate trusted central agencies and a cost involved. Dramatically reduce the cost of transaction. Blockchain is distributed, so somebody cannot compromise, hack into one computer and bring the whole system down. It is a distributed system, so it is immune to what is called denial of service attacks. That way it is very secure. Availability is almost guaranteed. The incentive system can reduce fraud by data manipulation. Manipulating data is not easy. The distribution of consensus and hashing ensure that, and there is an incentive to do it also. Everybody has an incentive to keep the system clean. So, it makes sure that data cannot be easily manipulated, and by implementing smart contracts, blockchains can link the cyber world with the physical world. I only release my cryptocurrency for buying something after ensuring that that product or service has been delivered to me. The delivery of product and service happens in the real world, physical world. The issuance of the transfer of the cryptocurrency happens in the e-world. Smart contracts links the two and make sure that when the physical part of the contract is delivered, the crypto part of the contract is delivered. Some of the disadvantages: the mining process, I said, is very complex, that makes the system very slow. Last time I checked, Bitcoin can only do 25 transactions per second, which is very slow. With millions of transactions happening around the world, it may take a long time for a block to be created and a block to be added, or between the transaction happens and the transaction gets added. And the thing is, we can trust a blockchain only when it is added. A block is added only when it is verified. The verification process is taking a long time. This may give an opportunity somebody to play hanky panky with the system. Not happen, but it can happen. It has become very slow. That is one of the disadvantages that can be overcome, though. There are methods people are already working upon. They already have implemented corrections to the Bitcoin algorithm to make it faster. The other thing is, since everything happens by consensus, if a bug is discovered in the program, it is visible to everyone. The moment somebody discovers a bug, everybody can discover, but it takes a long time to fix it, because somebody has to fix the bug, take consensus, get added. So, let us say even if it is for a few hours, somebody discovers a bug in Bitcoin or Ethereum or any other blockchain in a cryptocurrency, it takes 4 hours to fix it and distribute it to everyone. Within that 4 hours, somebody can exploit it, and such frauds have actually happened in the case of certain cryptocurrencies, not necessarily Bitcoin. In case of others, it has happened with Ethereum, for example. Somebody discovered a bug, it took some time to fix it. Already people had misused that within 4 hours to commit fraud. This is one of the dangers, real dangers of blockchain. Fixing errors is not easy. If Microsoft finds an egg, if Google finds a bug in Chrome, they can immediately invalidate that and send a fix to everyone and fix it. and they may not even announce it unless they make the solution available. They will fix the bug, then tell everybody go download it. They do not have to announce it in advance. Here it happens automatically. If the bug gets discovered, it will get announced immediately. So, there is always issues of security, lack of control. If somebody commits fraud on Bitcoin, they take away my Bitcoin, do not deliver the product. What is the recourse? I cannot go to courts because it is not recognized. There is no central authority governing that, making sure that the contract is honored. So, the lack of control, while it can be advantageous in some situations, many times it turns out to be a disadvantage. And there are lack of regulations, who maintains, what is the ownership, and finally, how does Bitcoin or any cryptocurrency exist? Cryptocurrencies or any proof of a transaction in a blockchain exists in a digital form as a set of bits and bytes. If I lose it, if I lose that and do not keep a copy, I lose. Bitcoin exists in the form of a number of digits. By mistake, that file gets deleted from my system, I do not have a copy. I lose the Bitcoins, I can nowhere recover, nobody can recover that. So, a lot of Bitcoins have been lost that way, a lot of currencies have lost that way. So, that is another big problem with blockchain in general. So, where all can blockchain be applied? These are the advantages, these are the disadvantages. As we have seen, some of the advantages are so powerful, like establishing trust transparently, removing middlemen, making transactions verifiable, having a distributed system which can withstand denial of service attacks. They are so strong that everybody is trying to leverage blockchains. Everybody is trying, including governments, private parties, banks, individuals, societies, everybody is trying to use blockchain as their fundamental building block. So, where all can be applied? It can be applied in any business where tamper proof verification is the foundation. That means anything. In fact, we are trying to use blockchain to maintain land records. Now, to prove, if somebody says I want to sell you this piece of land, I have to go to the office, government office, the registrar's office to find out if it is a valid document, and it may take a lot of time, money. Now, it is put on a blockchain, I can go there and verify. Government may want to charge me a fee to access the blockchain, fine, but if I go to the blockchain at my time, at my leisure, with my resources, I can go and verify that indeed this piece of document given to me is genuine, because there is a copy there and I can trust that. So, wherever we need transparent tamper proof trust and nobody could have tampered with that, we can use a blockchain. And then with automatic enforcement, with smart contracts, the moment I transfer my documents which are found to be genuine, person B cannot stop the Bitcoins from being transferred to me. That enforcement of the contract happens automatically. So, certain examples. These two are the key characteristics: transparent trust, automatic enforcement, and with the help of these two, we can replace the expensive intermediary by a one-to-one contract. So, some examples: cryptocurrencies, escrow for financial transactions, document maintenance, verification, notarization, supply chain management. There is an endless list of applications of blockchain. Some of these examples I have described in the other series of lectures on blockchain. This is an example of disruptive technology. I will not describe this again. I mentioned this in the very first lecture, how two banks by themselves can set up a limited credit card between them, which can be trusted by all their participants without involving expensive agencies like Visa, MasterCard and other credit card associations. Here I have taken the example of Karnataka Bank. So many financial applications are coming up on blockchain, they are constantly coming. Many financial organizations are devoting lot of time, effort and money to leverage blockchains. In fact, our RBI itself is recommended, it developed a set of guidelines for all Indian banks and financial institutions to use blockchains profitably. RBI itself is leading the example to make it highly usable. Any big name you can think of, it is there. JP Morgan, USAA, American Express, First Data, IBM, Intel, everybody is trying with blockchains. So, in Fintech, what is the role? By now you have seen there is no aspect of fintech which cannot depend upon blockchain, because fintech always deals with two parties who do not see each other. So, we need a way of trusting, and fintech depends upon removing the intermediaries and enhancing trust, and blockchain is the way to do it. We can ensure trust, reduce the cost by eliminating intermediaries, at the same time provide the equivalent level of trust in the system. So, number of applications and products are suitable. So, distributed consensus ensures trust transparently, we remove trusted central agencies, dramatically reduce the cost of transactions. Distributed nature, the nature that the blockchain is distributed, ledger is public and distributed, and encryption make the system very secure, tamper proof and immune to various kinds of hacking attacks. The incentive system can enable reduce fraud, it can implement smart contracts to ensure terms of a transaction. So, blockchains are heavily used in fintech, they are obviously foundation of cryptocurrencies and digital currencies. We will see this in a little more detail in a later lecture. They are used as escrow, remember third party which holds the funds till both ends of the transaction have been honored. They are used in capital markets for trading, very clearly we can see that. They are used as a foundation for P2P platforms, payment and lending platforms, used for micro payments, insurance, asset management, many others. This is about cryptocurrencies, I will cover that in a little later. Cryptocurrency is a digital currency that uses cryptography for security. Cryptocurrencies are generally anonymous or pseudonymous and not issued by a central authority. On the other hand, digital currencies are similar, except they are not anonymous and they are actually issued by a central authority. They do not have a physical form, they have a digital form. JP Morgan Chase has issued its own JPM coin. China is trying to introduce its own cryptocurrencies. They are actually digital currencies. They are not anonymous, they are not cryptocurrencies. Both are based on blockchains. This is about cryptocurrencies, I will skip that. Here is an example of various cryptocurrencies built on blockchain: Bitcoin, Ethereum, Cardano, Tether, Litecoin, Bitcoin Cash, various things like that, and more cryptocurrencies are coming up every day. Here is a set of P2P payment systems which are built on blockchain. The advantage is automation with smart contracts, eliminate intermediaries, transparency, safe and quick cross border payments. A number of things called products, Circle, Stellar, Ripple, we will see Ripple in a little later, Airfox are all P2P payment systems. Even NPCI, who have issued UPI, have released a blockchain based payment system called Vajra. I am not sure how accepted it is right now, but there is position papers, documentation is available on a blockchain based payment systems developed by NPCI called Vajra. SBI has joined one more blockchain based payment systems called Link, developed by the bank JP Morgan. So, even Indian players are getting into the act. There are a lot of lending platforms built on blockchains. There is a product in the US called Salt, P2P lending. There is something called Jibril network. There is an Indian company come up called Bank of Hodlers, which is also a P2P lending platform built on blockchain. For stocks and shares trading, there is a company called TradeBlock which has built its trading platform based on blockchain. This is an example of how the flow happens. So, a lot of P2P lending platforms also are being built on blockchain. So, as you can see, and pretty much insurance companies are coming on blockchain. So, in fintech, pretty much every aspect of financial services, whether it is an open public disintermediated blockchain or whether it is a private intermediated blockchain, every organization is trying to leverage blockchain to gain the efficiencies it brings into the system, gain the advantages, because they are so powerful, nobody wants to be left out without using the blockchain. That is the reason why we need to spend a little time studying blockchains in the context of fintech. As I said, fintech is not the only area where blockchains are used, they are used in pretty much any area, including retailing, logistics. I have given examples in the other series. Those interested, please go and follow that series of lectures. With that, we come to the end of the 8th lecture in the series on fintech. This lecture is being broadcast on channel 16 on the Swayamprabha program. Thank you.